Okay, this is your review. This is for 9th and 10th grade test review for the first part of circles, circle basics. This was some artwork done by a former student. Alright, so you're going to be given this huge drawing and having to label what some of the things are. You'll be asked different questions, and on the test it'll be things like, what is angle GDC? And you go look at GDC, you say, okay, that's a central angle because it's at the center. So you got to pay attention to the symbols, and then you'll have a choice of answers that will not be used twice, but there will be some leftovers. So make sure that you're paying attention. So let's just go through. Where are my inscribed angles? They're going to be on the edge, and there's several of those on here. So angle ABC, angle ABC would be one, or angle, let's see, the ones that are treated like it, ECB, technically treated like it, but it's not really called one. So be careful with that little part. Central angles. At the center we said GDC. There are several, CDH. There's one, BDH, GDB, right there, GDB. So at the center, tangent. You only got one tangent line, and that is here. I could call it EC, the segment. I could call it EF, the segment. I could call it CF. They're all part of that segment, and it all is where it hits. So the C doesn't have to be in there if you name the whole thing, but otherwise the C needs to be there. But pretty much any of those orders you can put in those parts. So radius, of course, from the center to the edge, a segment CD, that could be one, DH, DV, DG, all of them will have D in there. And you could turn the letters around, D, C, C, D, like that. Secant is a line that goes inside and outside, so that looks like that could be it, but I need to be careful. If I just name AB with a straight bar on top, with a straight bar, then I am just looking from A to B, and that's not a secant, that would be a chord. I want it to be inside and outside, and that would be a chord that's just on the inside. If I say line AB, and put the line sign on top of the symbol on top, then I'm going to say keep on going past A, keep on going past B, and so that would be a secant. I could call it just segment CB. If I did that, and look at, or so not C, it was E, I'm sorry, it was covered up. EB, if I say EB, then that's from E to B, and that has an outside part and an inside part. So that would be a secant in that case. Even if it didn't have this outside, it could have just one end outside, it's okay. Secant, like that. But just make sure you're looking at the pieces properly. Alright, a semicircle uses the same number of points as a major arc. So a semicircle, you know, is half a circle. So how are we going to know where half is? Look at your diameter. Your diameter shows you that. So it could be GBH, could be a semicircle. Or BHC could be a semicircle. Okay, you can go left or right, doesn't matter. You can go CAB, you can go CGB. All of those are arcs. What am I doing? Sorry, CGB. Major arcs are between, are less than 180. Major arcs are more than 180, but less than 360. So it has 3 letters as well. Don't get that confused with major arc. If it's exactly half, hitting that diameter, then it will be a semicircle. So even though it's got 3 letters, that's how you have to name a semicircle too. Alright, so minor arc is less than halfway. don't be the person that misses one. Like if I say AB, that's 2 letters. That means go the shortest route between A and B. That is a minor arc. Now people want to say, oh no, that's big, like obtuse. No, we're not talking about obtuse. We're talking about major arcs and minor arcs. And a minor arc is less than halfway around the circle. This would be halfway around here at C, so it is still less than halfway around. Minor arc. And there's several of those. A to B, A to C, C to H. H to B would still be minor. H to B. Alright, and then a major arc is going to be more than halfway around. So something like H, B, A. More than halfway around the circle. 3 letters, H, B, A, but don't get it confused with a semicircle, which is exactly half. Major arc has 3 letters, semicircle has 3, and the minor only has 2. Alright, and then of course your radius and diameter. Radius would be DC, HG. The diameter would go straight through the middle, one point to another. Remember, that's also a chord, but it's mainly the diameter. So segment BC would be a diameter. GH would be a diameter. Next, we have angle KOL is given to you, so you need to write that on your drawing in the right area. KOL, that's the angle. So these are all central angles. They're at the center, so they are equal to the arcs. We'll put your formulas on the board for you for that part. But don't just stop there. Say, oh, there's 90. See a block right there, 90. And then get the arc that goes with that. And now start thinking about how do I get the other 2 sections there. They're not vertical and I don't have any numbers, but I do have a diameter, 180. So 180 minus that 30 is going to give me 150 up top. And the same thing on the bottom. This makes 180 all the way around the bottom, so that'll be another 90. Now you go and you answer your questions over to the side. Angle NOK. NOK ends up being 150. NOK right in there. NOK. Alright, arc NM. That's right here where your 90 is. KNL. Be very careful. This is a tricky one. K to N. Don't go through the middle. Stay on the curve. Look at it. It's almost a full circle. Don't go KNL and shoot through the middle. That would be terrible wrong. So, how much? 360 minus the 30 would be the quickest way to add that up. You almost used a full circle, but we didn't use the 30. So that leaves you with 330 for number 9. All right. Next, you got the one like we did in class with the Raiders of the Lost Ark. You've got to fill in your 2 numbers, 25 and 80. So angle E is 25. No, where? D is 80. We're going to be looking for CE and DE. But remember, you've got your triangle in the middle. So it's the old easy triangle. Triangles add up to 180, subtract 80, subtract 25. Going to leave you with 75. Okay. So now, stop and think, what kind of angles are we looking at? Angle C is on the edge. It's an inscribed angle. And so the inscribed angles are half the size of the arc. As it starts right here at 75, it's getting bigger and bigger and bigger and bigger as it comes out. So you say times 2, and you'll get 150 out here. 75 is half. Angle is half the arc. 75 is half of 150. And then do that again with your others. So you'll have D. Angle D is 80, so this will be 160. And then the 25 opens up to over here, will be 50. You can check it. The outside adds up to 360 and make sure you got it all right. Yeah, 150. All right, so DE was 150 and CE was 160 for your missing parts. I'll go back. Well, the one I just skipped over, number 12 and 13, I can't make the video go back to the other drawing. On DC, if DC was equal to 2x, we had to something like this. How much would BC measure? Would it measure 4x? Is it true or false? So DC is a radius, BC is a diameter. So, BC would be twice as big, so that one would be true. Alright, and then finally, angle DCF. Now that is your tangent piece hitting up there. DC, where is it? No, I'm drawing the wrong spot. DCF be down here. So DCF, so here, here, and here, is that 90. What was the rule? When a radius hits a tangent, it always makes 90, so that would be true. But just make sure it's looking at the correct angle, DCF. Alright, a couple just extra to throw in there to follow along with the circle idea. These are arcs, and they're kind of hard to follow this way. If you want to, you could draw your little segment and put W, X, Y, and Z, because it's going to be arc addition instead of segment addition, but it works the same way. So if I gave you that WY, so from W to Y is 50, that's two pieces, right? Does it say they match? No, so don't put that on there. Alright, X to Z, that's another double combination, and that is 40. And then the whole entire thing is 80, from W all the way to Z. So we've done something like these before in the past. So just start with the whole thing being 80. If that part's 80, I could find the rest of this one little piece right here with 40. Because 40 plus 40 makes 80. Or I could come up to the top. 50 plus something makes 80, and it would be 30. But if you had the 40, you could go plug that in right there. 40 for that one piece. 40 plus what makes 50, that'll be 10. And then 10 and something else make 40, so that's your 30. Right there. So like segment addition, but it's arc addition postulate. So just don't let it freak you out. Alright, this was like the pizza problem. Some of y'all did this good, some of you didn't. It's kind of a ratio, it's a little bit more complicated than the other. If the clock hand moves 30 degrees, not 30 minutes, but 30 degrees, we want to think about how many sections are on a clock as you go around, and hopefully you know it is 12. So a clock is divided into 12 equal regions. So you can figure out how much is each little section out of the whole degree. So 360 divided by 12 gives you 5 degrees for each one. No, it's not. Is it right? Okay. That's the minutes. Okay, so it's 30. Each little section is 30. Yeah, I'm getting mixed up. All right, so 30 degrees for each one. So that means this is 30, this is 30, this is 30. Alright, so if the clock's only moved 30 degrees, then it's moved like one little section, so that would be 5 minutes worth of movement. I like doing ratios better with this. You're saying 30 degrees for the part you want. What's the whole amount of degrees? 360. Equal to time, how many minutes has it moved? How many minutes in the whole thing? 60. So you could do it this way as well. Cross multiply, and X ends up being 5 minutes. Same thing as you just did, but a different little twist to it. This was the minutes, this was the degrees, comparing each other. The part to the whole, the part of the minutes, the whole number of minutes, 60 degrees. So you pick how you want to do that one. Alright, this one looks real complicated, really simple, just kind of asking you to pick out the formula of anything. Angle BAC. What type of angle? It's outside. On the outside angle, you say the big arc minus the little arc divided by 2, and that should stand out at you right there. That's all you have to do. Or if I give you a little extra twist to it, what about CDB? Or what is it? CDB? Where is CDB? I can't see what it is on mine. They're too small on that screen. Yeah, CDB. What kind of angle is that? That's on the edge at D, so that is an inscribed, so all you're doing is taking half of the arc. What arc is it? BC. So BC divided by 2. That will be the answer. And that will go with that one. So let's just say picking out the formula for it. What's the form that goes with it? Alright, then you've got this where you're missing the arcs. So find the missing arcs going around 360, take away all the little pieces, and that's a 50 somewhere. Alright, you get the idea. And you end up with 150 left over for that missing piece. Okay. Alright, number 18, you're going to have, there's the center, but that is not a central angle. Angle TSU, TSU. The corner is not at the center, even though that is a diameter. But that diameter is going to help you find some missing parts. If that's the diameter, then this makes 180. I got 80, so this will be 100 over here for this arc. And before I used my formula, I had to know that missing arc. What just happened? It skipped. This thing won't go backwards. Alright, so let me redraw real quick. Skip both of them. Alright, so you had the center. Okay, so we have, here's your drawing, and we have the TSU. This angle right in here is what we're trying to find. So that opens up to this arc, but it's not a central angle and it's not inscribed, so this is one that you have to look at the verticals. So we're going to look for the arc that goes with TSU, and then we're going to look at the vertical arc. So it'll be 100 for one of them and 30 for the other. Add them up and divide by 2, and you end up with 65. Okay. All right. Then your second drawing, this is supposed to be number 19. Okay, so number 19, you've got 290 degrees for this big section right there. Get a different color here. So, let me change colors. Oh, right there. All that's 290. And it's obviously an outside angle. The C part is outside, so you got to say the big arc minus the small arc divided by 2. But you don't have the small arc, but you can figure out what this small arc is. They go from point to point. Mine's not drawn too great, but so if this part is 290, and then it picks up with the blue, just say 360, take away 290, leaves me 70 to go up here for this small part. So now I could set up my formula, 290, the big arc, minus 70 for the little arc, and then divide it all by 2, and I get 110 for number 19. Alright, number 20, we did some of these in class on the plastic sleeve. If I've got an angle here, what type of angle is it? That's a central, so it's going to equal the arc. Just go with what you have. 100 is the arc. When you come back, I'm asking you to find NOK. NOK is way back here. That's an inscribed angle. But I do have the arc now that goes with it. 100 is the arc, so inscribed, you take half, and this will be 50. Okay. Another inscribed angle right here. or you just find an x. You don't even need the angle. We just find an x. So there's a diameter. That tells me this half is going to make 180. So 2x plus 20 added to 4x minus 10 should equal 180. Get your x's together, 6x. Get your whole numbers together, 30. Equal to 180. Alright, so finish up. Move your 30. Get 150. 6 divides into 150. 28.3. Might be a decimal on the test, might not be, but just do the math like it does. Alright, and finally you got one of those combos like we did in class, but not near as difficult. You do need to start, before you worry about finding angles, find all the missing arcs. Remember, you look at your diameters. Here's a diameter this way, so this half makes 180. Well, that doesn't help us because we don't know anything. But on the bottom, you got a 180, and you know 2 parts. You're only missing this one thing. I got 20 and I got 60. That's 80. I need 100 right there. Now that half makes 180. So to get the other parts, you're going to have to look at a different diameter. So maybe look at it this way. There's going to be 2. All right, so this half makes 180. Put your pencil down, put the angle legs down, whatever you got to do. So I've got 120. This will be 60. And so I could have done vertical. Well, they're not always going to perfectly match, so be careful with that vertical. It does match if it's central, but it doesn't on the other. Now go back to where we had the diameter before. See that 180? This will now make 120. Now, is it vertical down here? Not with just that 100. It is with both of them. So you got to be real careful how you do your verticals. That's what I'm showing you. Just look at the diameters. Anytime you put the diameter down, it should show you where 180 is. And check some of the other ones. See that? 180. Check it before you go on. All right, then start with your easiest type, central angles, but be very careful. Where does angle B go? Like that? Is that just 100? How much of an arc is inside of there? 120. Central angle equal the arc, so angle B would measure 120. Be careful. All right, then angle, next type, there's no more at the center, so we'll do inscribed. Inscribed angle. A looks like an easy one right there. Comes down. Once again, that is 120 from leg to leg. But this time, since it's inscribed, we got to take half. So A would be 60. Alright. Angle C is one of those goofy ones. It's not at the center. It's not on the edge. So I want to make the X. I want to get my vertical angles, and that'll be right there. C would go with the 120, and the vertical goes with 20. So that's your adding them up and divide by 2. 120 for C, the vertical gets 20. Add them up and divide by 2. Angle C is 70. No, it looks a little different on my paper. Alright. And then finally, angle D is on the exterior. But still, take those angle legs, take the time. Don't worry about any other stuff. Even if you got numbers up in here for A and B, we're only looking at the curve, the arc. 20 is the arc inside of there. 60 is the arc. None of this other stuff is arcs. That's just angles. So your formula is big arc minus little arc divided by 2. So 60 minus 20 divided by 2. And that'll give you 20. So our answers are 60, 120, 70, and 20. Good luck.